So this is for our friend Jerry, Mr. G Math coming at you live, right? Room 7202, beautiful Tuesday morning. Today's lesson is on graphing derivatives and anti-derivatives. What do you think an antiderivative is? Not a derivative. So it's not just not, right? It's actually the exact opposite of a derivative, right? So it's not just not, like purple is not red, but kind of stuff. Like they're connected, right? It's not that it's just not. It's the exact opposite, right? Okay. If you have a function and you do the derivative, and that equation you graph, that's graphing the derivative. If you go the other way, you're given the derivative, and you can work backwards, then you're graphing the function. And of course, if you take the derivative of the derivative, it's now the second derivative. The key is this, that when I say derivative, you say slope. Can you think that? So if I say derivative, what do you think? Slope, right? When I say derivative, slope. So when I look at number one, what's shown? The function. And don't think it's like Kentucky Fried Chicken. It's not like the original and then the new and improved. Function, first derivative, second derivative. So what are you given? The function. And then what are you asked to graph? The first derivative. And how are you going to do that? By understanding the slope. Yes? Yes. So notice there's an endpoint. Do you know that from -4 to -2 there's a slope? Is that slope positive or is that slope negative? Good. When I look from -2 all the way to +2, what do you notice? It's negative. When you look from +2 to 4, again, it's... So when I graph, at first it's going to be positive. Now for the derivative, positive means it's going to be above the x-axis. If it's negative, it's going to be below. So from negative, whatever that is, 3.5 to -2, is the slope positive or negative? Does that mean it's above the x-axis or below? Above. So when I look from -3.5 to -2, the graph is going to be above. I don't know the picture yet, but I know it's above. From -2 to +2, the graph is going to be below. And then from 2 to 4, the graph is going to be above. I'm going to throw another thing at you. Is there a concavity change in this? So where's the concavity change? Approximately. When x equals 0, right? For the derivative, that creates, because remember, when you take the first derivative equal to 0, right? In terms of what's happening, that, where the horizontal tangent is, that creates a point of inflection. So, do you see this up here? What kind of tangent is there at -2? When x is -2, what's the slope? 0. So guess what I'm going to put right here? Let's start easy. So do you know why I put a 0 there at -2? Because the slope at -2 is 0. Where else is it 0? Let's start there. At +2. The concavity change is going to create either a local minimum or a local maximum for the derivative. When the derivative changes from decreasing to increasing, that change of the derivative creates a point of inflection. Since in this case, if you look, it's going to be above, 2, below, and then change. When does the concavity change? Now, are we given any information here to know exactly where that is? And the answer is no. We're not given information to know where it is, so we're sketching it. So somewhere here, if you put it at -1 or -2, it doesn't matter, but it matters that it's below, and it matters that it changes. So it's decreasing, and then it increases. This is an indicator right here that there's a point of inflection. I know that the graph ends at -3.5. So somewhere here, there's an endpoint. We're going to come back to understand this. And then it ends on the other side at 3.5. So I want you to think with me backwards again. You're willing to be open-minded, right? What did this tell me? From negative 3.5 to negative 2, what is the slope, positive or negative? Okay, it's above the x-axis. So don't look at the derivative and say it's decreasing. Look at the derivative and say, is it above the x-axis or is it below the x-axis? So from negative 3.5 to negative 2, what is it? Above, which means it's positive. So if I go back a step from negative 3.5 to negative 2, because the slope is positive, it is increasing. There's a connection there. From negative 3.5 to negative 2, it is increasing. Therefore, this better be positive. Between negative 2 and positive 2, the graph is doing what? Decreasing. So that means between negative 2 and 2, it better be what? Below. What's happening exactly at 0 is there's a concavity change, right? So that means the slopes are going from being negative to going to becoming positive. In other words, it's going from a frown to a smile. Negative slopes frown, positive slopes smile. There's a lot of connections here looking at the graph. And then at the end, 2 and greater, what happens from 2 to 3.5? Again, it's increasing, which means it needs to be above. That's a lot to absorb in, right? Looking at the graph of an antiderivative, or of a derivative. So if I'm looking at the derivative, and the graph is above the x-axis, what does that tell me? That it's increasing when I look at the function, right? This, I'm not looking at increasing or decreasing. I'm looking, is it positive or negative? So if it's positive, that means my function is increasing. If it's negative, that means my function is decreasing. And again, if it's positive, it is increasing. What do the X-intercepts tell me of the derivative? A relative maximum or a relative minimum, unless they don't cross. If they only touch, they don't create that. So do you see how it crosses over? From positive to negative, what does that create? Positive to negative, what did it create? A maximum. And if it crosses from negative to positive, what does it create? A minimum. All the information's there, but you need to practice. So if I look at the X-intercepts of the derivative, they're going to give me the relative max or the what? If they cross over. If they just touch, then it doesn't, because that's a change from positive to negative and negative to positive. If I did a first derivative number line, right? The only numbers that would be on my first derivative number line would be negative 2 and positive 2. You would say positive, negative, and positive if you looked off the graph. And these are endpoints, right? From the left end to negative 2, is it above? From negative 2 to 2, is it below? And from 2 to the end, is it above? If a graph goes from positive to negative, what did it create? A maximum. If it goes from negative to positive, what did it create? A minimum. Can you see how there's different ways to see the derivative and its function? Looking off a graph. This is going to take practice, right? Okay, let's look and read about antiderivatives. Antiderivative is going the other direction, right? The opposite direction. You're given the derivative and you're going to graph the function. So, what did they say first to do? Make a what? A first derivative number line. Why? Because that tells you where it's increasing and it also tells you any extrema, right? Relative max or min, right? And remember, it says this does not involve the slopes. Why is it telling you? It's, is it above the x-axis or is it below? If you really want to know, the slopes of the derivative tell you concavity. You didn't want to know, right? So, then make a second derivative number line, right? By using the slopes. And then when you look at that, that's going to tell you the concavity, and then you put it together. We're going to practice, you're going to practice, and we'll practice some more. You got that? Believe. That's part of it. When I go to Disneyland, that's always the theme. Believe. So let's start with the first derivative number line. Can you tell me where this first derivative is equal to 0? What are the critical numbers for x? Negative what? This x coordinate. Where is it 0? And there's endpoints, so dare I not put arrows at the end. So, negative 3.5. Where else is it 0? 0. Where else is it 0? 3.5. So can you see where I get the critical numbers from? I looked at the x-intercepts. Where did I get the critical numbers from? I looked at the x-intercepts. Soaked in.
Why do we put negative 3.5 and 3.5 in between the points? Aren't they the points?
I'm creating intervals, and I want to know if it's above or below the x-axis to know where it's increasing and decreasing. So, the end to negative 3.5, right? In fact, negative 3.5 is the end. Is that what you're telling me? Yes, thank you, Candy. 3.5 is the end, right? So the only number in the middle is what? So from negative 3.5 to 0, is it above or below? So positive. From 0 to 3.5, is it above or below? What did I just find? That from negative 3.5 to 0, the graph is what? And from 0 to 3.5, it is? Beautiful. And so what's happening at 0? Increasing to decreasing. What happens? When x is 0, there's a relative? Beautiful. Second derivative. Now we're looking for, when you look at the first derivative, where are the slopes 0? In other words, where is the relative max and min? At what values? Negative 2. Remember, we have endpoints. So at negative 2, where else do we have a horizontal tangent? And if we had any spot that was undefined, we'd put it on there too, but we don't. Now we're looking at the slopes. In other words, is it increasing or decreasing? So the end to negative 2, increasing or decreasing? Say increasing. That means it's concave up for my function. From negative 2 to positive 2, what's happening? Which means it's going to be concave down. Getting information off the derivative takes practice. Last, from 2 to the end of the graph, increasing or decreasing? What we just found with the second derivative number line is the what? Concavity. Now we're going to put this together. Notice they give us a starting point. Where's their starting point? Beautiful. Can we put that down? Now I know actually that point is actually a relative maximum. Why do I know it's a relative maximum at 0, 1? At 0, there's a, and they gave us the point, right? What else do I know that I can find out here? So what's happening from negative 3.5 to 0? Is it increasing or decreasing? It's increasing. And what's happening at negative 2? What happens at negative 2? It changes concavity, right? So I know it's increasing, and then it changes concavity. So, from negative 3.5 to negative 2, is it going to frown or smile as it goes up? It's going to smile. Can we do that? Smile. What happens from negative 2 as it increases? Instead of smiling, it frowns. Smile, frown, endpoint. Smile, frown. Do I know the x-intercept? No. It's a sketch of the shape. It could be shifted up or down a little from there. What happens from 0 and then what happens at 2? Is it going to smile or frown? It keeps frowning. So in fact, it frowns from 2 to... So from negative 2 to 2, it frowns, and then after 2, it's going to smile. Notice, oh, and that's not arrow, endpoints. So notice, it increases and then it decreases. We have a relative maximum. It smiles, it frowns, and then it smiles. It's putting the concept of increasing, decreasing, and concavity all together. And believing in yourself and practice and practice. All right, let's finish this before the bell rings. So number 3. You're not going to learn this right this second. You're going to learn when you go home and practice and come back with questions and at lunch and so on. Okay? I'm just setting it up for you. All right, look at the first derivative. Can you tell me where I should look to see the critical number for the first derivative? If you say anything but the x-intercept, I'll be mad. So where's the x-intercept? That's the only one. Notice there's arrows at the ends, right? So the only critical number there, right, in terms of that is negative 2. That's it. To the right of negative 2, is it above or below? So to the right of negative 2, it's above, so it's positive. To the left of negative 2, it's... So what I found was the function decreases and then it increases. So at x is negative 2 creates a what? Creates a relative minimum. Whenever the derivative crosses the x-axis, it creates either a relative max or a relative min. Negative to positive creates a min. Positive to negative creates a max. Look at the second derivative. What do you notice? There's one place where the slope is undefined, or where the derivative is undefined, I should say. And that's when it's at 0. Remember that if it changed, are there any horizontal tangents here? Did it change from increasing to decreasing? No. But is there any place where the derivative is undefined? When it's 0. We need to put that down. But when I look at it, is it increasing everywhere or does it decrease at all? Everywhere. So what did I just find? Because it's increasing everywhere. The whole graph for the function is smiling. The whole graph is concave up. And where's the minimum? When x is what? Negative 2, right? And it's concave up. Now, what does the graph look like for the second derivative? We even do that, working backwards. What's the slope here? Rise over run? Positive 1, correct? So can you see where positive 1 is? And right on the y-axis is going to be a hole. Why is there a hole here? Because it's undefined there. But everywhere to the left, the slope is always what number? 1. What shape is this right here? A parabola, right? If you take the derivative of that, and if you would estimate what that equation would be, it would be like x squared plus 2, right? Can you see that parabola up 2? If you took the derivative of that, what would it be? Does it really matter about the 2? 2x. Can you graph the line 2x? Where does it start at? 0. But guess what's going to be at 0? A hole. And then what's the slope? Up 2 and to the right 1. And it goes forever this way. So can you see the horizontal line and the slanted line from the first derivative? And now we're going to end it off. What does the actual function look like then? So where is the minimum? At what x value? At negative 2. They don't even tell me what the y value is. So I'm just going to put negative 2 right there. There's my negative 2. What happens to the left? What happens to the left? Decreasing. What happens to the right? Increasing. And the whole thing is what? Concave up. Does that sketch represent the derivatives? Is it concave up everywhere? Does it go from decreasing to increasing? And it's the ability to analyze a derivative, a second derivative, and a function graphically. And I just introduced it to you. How are you going to learn it? Is by on your own, right? And with me and with friends, right? To figure this out. Don't forget your calculator on Thursday. Oh, and Friday after school? You know your test is on Monday, right? Did you know that, looking off the calendar?
Yeah.
So, on Thursday, this is for the video too, is a review day. No new topic on Thursday. But, Friday after school, if you're available, we're going to go over what the test is going to look like so you can prep over the weekend. So Friday, right after school, will be very worthwhile. I know the bell game, but the bell game doesn't start at 2:35. So, Friday, right after school, I won't keep you till like 6 o'clock, I promise. I want to go home too. So Friday, right after school, before the bell game, so you can set up your studying for the weekend, okay? That's for you too over there in Video Land. So I hope Santa Barbara was worth it. Bye.